These are the Lesson 11-2 notes on arithmetic sequences. Today we're going to identify arithmetic sequences. We're going to find the missing term of an arithmetic sequence, find future terms of an arithmetic sequence using an explicit formula. We'll write explicit and recursive formulas for arithmetic sequences, and we'll find the first term and common difference of an arithmetic sequence using two terms. First of all, to identify an arithmetic sequence, what we're looking for is a constant difference. That is, what we're going to look for is between terms, the numbers should be increasing or decreasing by the same value. Think of repeated addition or subtraction. For example, in the first sequence, you can think of the difference between these terms as being 1. They're increasing by 1. To get from one term to the next, you could add 1 to get from one term to the next. So this constant addition and subtraction by the same number means that this is an arithmetic sequence with a constant difference of 1. Our second set of numbers, 13, 10, 7, 4, is decreasing by 3. You could subtract 3 to get from one term to the next. This has a constant difference of -3. That means this is an arithmetic sequence. Now this set of numbers, we are putting an additional 1 on the end each time. There is a pattern here, but it's not repeated addition by the same value. You could think of we've added 10 here to get to the next term, then we've added 100 to get to the next term, then we've added 1,000. We're not adding a constant value each time, so this is not an arithmetic sequence. For 2, 4, 8, 16, again, there is a pattern. In this pattern, we're actually multiplying by 2 to get from one term to the next. However, it's not repeated addition or subtraction, it's repeated multiplication, so that's not an arithmetic sequence either. 2, 4, 6, 8. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. There is a constant difference that we're adding or subtracting by, so that would be an arithmetic sequence. So again, we're looking for constant addition or subtraction. To find the missing term of a sequence that's arithmetic, let's look at this first one, which goes 10, comma, blank, comma, 4. We're looking for what the missing term is. So some of you might be able to kind of guess about where it is. What is it though? Well, to find the missing term, we're going to calculate something called the arithmetic mean. Another name for the arithmetic mean is the average. Now, for the average of 10 and 4, you know how to find an average. You add and you divide. So we're going to add these two numbers. 10 plus 4 is 14. Then we're going to divide that by 2. And 14 divided by 2 is equal to 7. That is the missing term, and it should make sense because what's the constant difference? Well, to get from 10 to 7, you subtract 3. To get from 7 to 4, you subtract 3. There's your constant difference. D is equal to -3. What I'd like you to do is I'd like you to pause the video and see if you can find the missing term of these two arithmetic sequences. So for the first sequence, the missing term is 15. This makes sense because to get from 9 to 15, you have to add 6. To get from 15 to 21, you have to add 6. That's your constant difference, 6. To get from 3 to 12, again, you find the average. If you add 3 and 12, you get 15. 15 divided by 2 is 7.5. That makes sense because to get from 3 to 7.5, you have to add 4.5. And to get from 7.5 to 12, you have to add 4.5. D, your constant difference, is 4.5. Now let's find future terms of an arithmetic sequence using an explicit formula. The explicit formula for an arithmetic sequence can always be written in this format right here. Now you may recall a sub n stands for any term. So to find any term in an arithmetic sequence, we're going to take a sub 1. Now a sub 1 is the first term of the sequence. And we're going to add n minus 1, n stands for the term number, minus 1, times d, which we've called the constant difference of our arithmetic sequence. We're going to use this formula to find the 20th term of the sequence that starts 1, 3, 5, 7. Well, to find the 20th term, we want to find a sub 20. So that's the term we're trying to find, a sub 20. N is 20. A sub 1 is the first term of the sequence, which in this problem is 1. N is the term number we're looking for. That would be the 20th term. We're going to subtract 1 from that number, and we're going to multiply this by the constant difference, what the numbers are changing by. These numbers are increasing by 2, so D is a positive 2. Now obviously you can use your calculator to crunch this out. You can also crunch this out, I think, without a calculator. 20 minus 1 is obviously 19. Order of operations says once you do work in parentheses, do your multiplication next. So don't do 1 plus 19 is 20 times 2 is 40. Now 19 times 2 is 38. And do 1 plus 38, which is 39. That makes more sense. 40 wouldn't make sense because it's an even number and it appears that all of our terms are odd. Let's see if you can use this formula to find the 1,000th term of this sequence. Notice the constant difference in that the numbers are getting smaller, so that impacts what your d value is equal to. Pause the video, we'll see what you get in just a minute. So to find the 1,000th term, we're going to take the first term, 9,999, plus n, the term number, which is 1,000, minus 1, times the constant difference is negative 1 because the numbers are decreasing by 1 each time. So 1,000 minus 1 is 999, multiplied by negative 1 is negative 999, and if you add that to 9,999, you get 9,000 for an answer. So writing explicit and recursive formulas for a sequence involves some of the same operations that we just worked with. For example, to write the explicit formula for this sequence, we are going to start off with a sub n. I'm going to plug in the first term, a sub 1, which is 14, plus, now instead of doing n minus 1 and replacing n with a number, n could be any number or any term number. So I'm just going to leave this as n because I'm not looking for like the 5th term or the 6th term. I'm just writing a formula, so I need a variable. And we're going to do minus 1 times the constant difference, which is 3. Don't substitute for n. The recursive formula is pretty easy as well. We know what the first term is. A sub 1 is equal to 14. And then you can find any other term by taking the previous term and adding 3. And there's your recursive formula. What I'd like you to do is I'd like you to pause the video and see if you can come up with the explicit and recursive formulas for the sequence 20, 18, 16, 14. So for our 20, 18, 16, 14 sequence, our explicit formula is going to be a sub n equals 20 plus parentheses n minus 1 times negative 2. Make sure you put parentheses around the negative 2 because otherwise it looks like you're doing n minus 1 minus 2, and that's a different sequence. So if you're ever multiplying by a constant difference that's a negative number, be sure and put parentheses around it. Your recursive formula, a sub 1 equals 20, a sub n equals a sub n minus 1 minus 2. Our last thing we're going to do is we're going to find the first term and common difference of an arithmetic sequence given two terms. Let's take a look at this first example. A sub 3 equals 10 and a sub 7 equals 11. Our goal is to find a sequence of numbers. We want to start with a sub 1, which we're not sure what that is yet. Then we're going to have a sub 2, a sub 3, which is 10, a sub 4, sub 5, sub 6, and a sub 7, which is 21. And our goal is to figure out what the first term is and then what are the numbers going up by. So what we're going to start with is we're going to start with our arithmetic sequence formula, a sub n equals a sub 1 plus n minus 1 times d. And I'm going to do a couple of substitutions, kind of one on the left side here and one on the right side. I'm going to start with this a sub 3 equals 10. What I'm going to do is I'm going to plug in 3 for n first of all. So all I'm going to do in this expression here is I'm going to plug in 3 for n. Wherever I see an n, I'm going to plug in 3. I really don't know many of the other values on here. What I do know, though, is I do know that a sub 3 is 10. So I'm going to replace the a sub 3 in this equation with a 10. So I have 10 equals a sub 1 plus 2d. That's what 3 minus 1 is. Now I'm going to do the same substitution with a sub 7. It says a sub 7 equals 21. I'm first going to plug in 7 for n. So it's going to give me a sub 7 equals a sub 1 plus 7 minus 1 times d. A sub 7 is equal to 21, so I'm going to replace the a sub 7 with a 21. And 7 minus 1 is equal to 6. So now I have two expressions. If I solve for a sub 1, if I get the 2 to the other side here, this is actually 2d. If I get the 2d to the other side by subtracting, what I'm going to end up with is 10 minus 2d equals a sub 1. In my other expression, I can also get a sub 1 by itself, this time by subtracting 6d. So I have 21 minus 6d equals a sub 1. And both of these are equal to a sub 1, which means that if a sub 1 equals this, and a sub 1 equals this, then these two expressions I've underlined are equal to each other. So we're going to say that they are equal to each other. 10 minus 2d has to be the same thing as 21 minus 6d because they're both equal to the same thing, which is a sub 1. Now we're going to solve this algebra equation. Number of different steps you can do. I'm going to add 6d to both sides just to get rid of this negative 6d. So I have 10 plus 4d on the left side equals 21. I'm going to subtract 10 from each side to get d by itself eventually. This gives me 4d equals 11. And then the last thing I'm going to do is divide both sides by 4. Doing this is going to give me d equals 11 over 4, which is also equal to 2.75. That's my constant difference. To figure out what the first term is, I can go to one of these expressions I've underlined to figure out what a sub 1 is. I'm going to choose this expression right here, the one that says 10 minus 2d equals a sub 1. Since d is equal to 2.75, I'm just going to replace the d with a 2.75. And if you do 10 minus 2 times 2.75, this is actually equal to 4.5 if you crunch that out. That's what a sub 1 is equal to, which means the first term is a sub 1, which is one thing I'm trying to find. And if the terms go up by 2.75, what you get is 7.25. You actually do get 10 here. Then you get 12.75, 15.5, 18.25, and finally 21. It does work. What I'd like you to do is pause the video, see if you can come up with the first term and common difference of this sequence that's defined by a sub 4 equals 16 and a sub 8 equals 44, and we'll take a look at your answer in just a moment. By setting up some similar formulas for this example, you should eventually be able to solve for d. d in this problem ends up being really nice. It ends up being 7. a sub 1 in this problem ends up being negative 5. And the problem checks because if you look at the first 8 terms, if the first term is negative 5 and you go up by 7s, you should end up with negative 5, 2, 9, 16 for your fourth term, 23, 30, 37, and 44 for your 8th term. If you have questions about the math, you can see me during class. Otherwise, this is your assignment that deals with arithmetic sequences.